Yeah, you did. All right, 2.4, like I said, it's word problems. We're going to look, see what they want us to find, work until we get it. Okay, we're going to start now. So put your phones away. Headphones should not be in your ears. You should focus on this. It says Jacksonville, Florida has an elevation of 12 feet above sea level. A hot air balloon taking off from Jacksonville rises at 50 feet per minute. Okay, so far I've got 12 feet above sea level and rises 50 feet per minute. Those things seem important. Write an equation to model the balloon's elevation as a function of time. If it says function of whatever, that whatever is your x. Okay, so time is going to be our x. And then we're going to graph the equation, and then we will interpret the intercept at which the graph intersects the vertical axis. Lots of interwords there. But first we need to write our equation. So let's kind of figure out what we're talking about. We need to figure out the balloon's elevation. The elevation is going to be our y. We'll get to that in a minute. So elevation is going to equal, well, it starts somewhere, so starting elevation plus the elevation that it gains, right, as it keeps going. Okay, so that's going to be its distance. Which was the formula for distance? Physics? Close. Speed times time. It's rate times time. Okay, define, we've actually kind of already done that. Y, we said, is going to be our elevation, which is going to be in feet, because that's what it gave us. X is going to be time, which, according to that rate, 50 feet per minute, we're going to use minutes. Okay? Now let's write our equation. So instead of elevation, oh, somebody changed it to the lightsaber. And saber, I said saver, sorry. Elevation, I can't handle that, is going to be y. So y equals, what was the starting elevation? I spelled
12 feet above sea level.
12 plus, what is our rate? 50 times time, which is x. Let's do green. All right. So we've finished the first part. We've written an equation. Now we need to graph the equation. Oh, man. All right, so our y, we said, is feet. Our x is minutes. And our feet, I feel like we're going to go pretty high. You know, it's rising at 50 feet per minute. Okay, so why don't we do this? Do 50, 100, and we'll have 150. And our time will go by, we can go by 1. So 1, 2, 3, 4. Okay, you can kind of figure out what you want on these things based off your slope, really. Because our slope, we go up 50 and over 1. So these will be pretty good units. But where do we start our graph? At 12, because that's the y-intercept, right? If you want to write this as y equals 50x plus 12, so it matches up with y equals mx plus b, that might help you to see that 12 is our intersect. y-intercept.
Minus 12.
We wanted y by itself, so that's good. Now we just need to take this 12 and put it over here somewhere on the graph. So let's see, 50, so there's 25, so about halfway, so right there, about. It's going to be our 12. And from there, we go up 50 over 1. Up 50 over 1. So you can approximate here. And then we'll draw our line. Should be a straight line. Mine was a little off. Then our balloon and both our height and our time can't be negative. So we don't draw an arrow on both ends, only on the end going up. So last thing is that we have to interpret the intercept at which the graph intersects the vertical axis. So it intersects right here. So what did we say that point is? 0, 12. Okay, the 12, what is that 12? It's y-intercept, but in like the situation. Do it? It's feet, yes, it's the starting point in the trip, right? Starting height, specifically, which, as Paul said, is feet. Starting height of trip. That's supposed to be an R. Okay, and what's the 0? You haven't taken off yet. It's the starting time of the trip. Because we got to start at 0 minutes. Time in minutes of the trip. Very good.
You read chapter 8?
Chapter 8? What?
Chapter 28.
Oh, I was like, we're on chapter 2, man. It's real confusing. All right, any questions over the hot air balloon question? No? All right, let's deal with the next one, which talks about a candle. A candle is 6 inches tall after burning for 1 hour. After 3 hours, it's 5.5 inches tall. So it only lost half an inch in 2 hours. Let's see. Write an equation, a linear equation, to model the height after burning X hours. Hey, it just told us what X is going to be. It's going to be the hours. So there's an X, and there's an X. So that must be the height is Y. So there's a Y, and there's a Y. So let's write that down here for our step 1. We're going to have 2 points. First we'll have 1, 6, and then our second point will be 3, 5.5. And we're trying to get a linear equation, so what's like the most basic form of a linear equation? Y equals, y equals X. What is it like, the formula that we graph from? Mx plus B. So we have 2 points which can help us get our slope, right? M. What's the formula for slope?
Y2 minus Y1 over X2.
Yes. Very good. So if we plug into that, what's X2? It is, I said X, you're right. 3 minus 1, what goes on top? 5.5 minus 6. Negative 0.5 over 2. What do you get when you put that in the calculator? Yes. So it's a half, you divide it by 2, so you get 0.25. What is that as a fraction? -1/4. Okay. With slope, remember that it's easiest if it's in a fraction, because when it's on the graph, then you can just go up and over, up and over. Okay. So there's our slope. Doing good. That's step 2. Now step 3, we need to use the information we have, plug it into one of the forms, and then we'll be able to simplify and get our line. So we don't have the intercept, so we can't plug into this one. Which one can we plug into? Y'all remember the other ones? Point what? Point slope, yes. So what is point slope? Do y'all remember? Y minus y1 equals m times x minus x1. And you can use either of these points. That one has decimal, so that's weird. So I want to use this one when I plug in. So I'll put the 1 down here for x1 and the 6 down here for y1. So we get y minus 6 equals, our slope is -1/4, x minus 1. From there, we'll simplify and distribute. Y minus 6 equals -1/4 x plus 1/4. Doing good so far. Because I work at it. I don't know.
Do you have to think about the stuff you do anymore?
Yes, I definitely do. Okay, so Kobe, trying to get the y by itself. What should we do with that 6? Add it. Good job. So if I add 6 over here, cancels that one out. But 1/4 and 6 are like terms, so we can combine them. Let's make a common denominator. So I'll put a 4 underneath the 6. So what does that mean happens to the top? Gets multiplied by 4, so now it's 24. 24/4 is the same thing as 6. Now combine them, and we'll get y equals -1/4 x plus 25/4. There's our answer. X, if you remember, is time in hours. Y is height in inches. We are going to use the formula from the problem we just did on this one. It says use. It's echoing now. Is it? Just barely. Maybe we'll keep going and see what it says. Okay. Hello? Hello? Okay. It's not echoing. Hurrah. Back to what we were doing. Sorry for the 30 seconds of gibberish. We're going to use the equation from example 2 to answer the following question. So let me first write down that equation. It was y equals -1/4 x plus 25/4. Our x was time, right? In hours. And y was height in inches. That'll be useful so we can keep things straight over here. All right. We have 3 questions. They're all kind of separate, so we'll handle one at a time. First one, in how many hours will the candle be 4 inches tall? Okay, so it's asking for hours, so that means it's asking for an x. but it gave us a y, which is 4 inches tall. So all we have to do is plug in. So we're going to plug in that y equals 4. So that's 4 equals negative 1/4 x plus 25 over 4. You good? So we're trying to find x. So let's subtract 25 over 4 to the other side. Let's see. So those cancel, but I want to combine these two. So I need to put 4 is the denominator right here. So if I divide by 4, what does the numerator become? 16. So what's 16 minus 25? Negative 9?
Yeah.
Yeah. So negative 9 equals, negative 9 over 4 equals negative 1 over 4x. How do I get rid of that negative 1 over 4? Okay, so we need to divide it. Divide by a fraction is the same thing as multiplying by its reciprocal. So what's the reciprocal of negative 1 over 4? Negative 4. Multiply both sides by negative 4. So all that cancels. The negative's gone too. The 4's can cancel. And what's negative times negative 9? Positive 9. 9 what? Hours when 4 inches tall. Okay, so it took 9 hours for it to burn down to 4 inches. All right. That's the first one. The next question is, what was the original height of the candle? So it's asking us for height, which is y. So we're looking for a y. So what do we know about the x at the original height? X is time. So what's the time when the candle's at its original height? 0, right? It hasn't burned at all. So x equals 0. And we'll just plug that in. Y equals negative 1/4 times 0 plus 25 over 4. What's anything times 0? 0. So that's gone. So what is the height, the original height? 25 over 4 what? Inches is original height, which is like 6 point something.
This is just too easy. That's what you're saying.
My squigglies die off. One more. I've been writing too big. When will the candle burn out? They said when, so it's looking for an x. We'll assume that the candle goes all the way down before it burns out. So what's the height going to be? 0. So that's y. So when y is 0, we need to know x. So we'll say 0 equals negative 1 over 4x plus 25 over 4. Work this the same way we did the first one. So we're going to subtract 25 over 4. Subtract 25 over 4. So we get negative 25 over 4 equals negative 1/4 x. Multiply by the reciprocal, which is negative 4. Multiply by negative 4. It all cancels on the right side. On the left side, the 4's cancel. We still have 2 negatives, so that makes positive 25. We were looking for x, which is time. So 25 hours when height is 0. 0 inches. That candle burned for a long time. It must be, and it was only like 6-something inches to start out with. So you think it was probably like really wide, right? Big diameter. Probably. Okay.
I don't understand why don't they make a candle that just like how candle wax refreezes or like gets all stiff? Why don't they just make one that just makes itself over?
That's kind of like what the Scentsy things are that heats it up like from the bottom
Yeah,
and it
but
just
does-
melts it.
It doesn't smell.
Yeah, I think that's the issue with the candle that remakes itself too.
Yeah, maybe I don't know.
Yeah,
Maybe some cool person will invent a
maybe so.
2-year candle.
All right. So have y'all seen graphs like these before?
Yes.
What are they called?
Scatter.
Scatter plots. Fantastic. That goes in the blank. So a let me try again. That's horrible handwriting. Human. Scatter plot is a graph that relates two different sets of data by plotting the data as ordered pairs. Okay, so x's and y's. You can use a scatter plot to determine a relationship between the data sets. So their relationships we can categorize. First of all, we can say if they have a positive relationship, so as one goes up, the other one goes up. They look like that. Or a negative, as one goes down, the other goes up. Okay, so those are negative. And then we can say whether it's weak or strong. Okay, so weak is scattered out. Strong, they're really tied in close together. All right, and then when they're just all over the place, that's no correlation. They really don't have a relationship. Okay? Now, let's use this. Oh, and then when you kind of estimate a line from that, so you could like draw a line in the middle of that one, that's called a trend line. Okay, it's the line that follows the trend of the points. And we can use that to make predictions, which is what we're going to do next. Hurrah! Okay, on your homework, I actually think that the examples or the problems like this aren't word problems. So we're just going to do this one, and then there won't be word problems on your homework. A woman is considering buying a 1999 car that is listed as $4,200. This problem may be a little old. Maybe. Okay, she researches prices for various years of the same model and records the data in a table. All right, so here is her table right here. So she got the years 5 above what she wants and then got 2 prices for all of them. All right, this is probably like a Toyota truck or something. Those keep their value really low. All right, let X represent the model year. Okay, so it just told us what our X is. It's model year. And we are going to, instead of putting on our graph like 2000, 2001, 2002, we are going to replace those with starting with 1 and just going up from there. 1, 2, 3, 4, 5. Okay, so year 2000 is 1. And then they just went by ones after that, so we could do 1, 2, 3, 4, 5. Okay, you can do that. When you've got giant numbers, you can replace them as long as you like make a note like this of what it represents. Whoops, wrong one. What it represents, okay? It says let Y be the price of the car. There's our Y. And now we have to draw a scatter plot. Yay. So let's make some axes here. This one is Y, which is price, so that's dollars. This one's X, which is year. Okay, our years, we know we're going 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then the price, though, let's see, what's the lowest price that's on that chart?
5,435.
Okay, so somewhere around 5,000, 5.5, and then the biggest price is up at like 11.
Shit, that's broke.
So let's see, what do y'all want to go by? 5,000s? Maybe like 3,000s. 2,000s, 3,000s. What'd you say? 2,000s. Okay. So let's make that 2,000, 4,000. Yeah, you can do Ks if you want. So 2K, 4K, 6,000, 8,000, 10,000. My graph is almost even. Alright, so for our points, just take these on there. So for year 1, we're going to have a point at 54.35, so somewhere right around there, and then almost to 600 from that 57. So 2 points go with the 1. And then 2 points go with the 2, just above 6,000. And almost halfway between 6 and 8,000. For 3, year 3, we've got 77. So almost 8,000. And then just above 8,000 for the 82, 37. Year 4. It's around 9,000, so that's halfway between the 8 and the 10. And then a little closer to the 10. For year 5, we actually go above 10. And then above that. Okay, so yes, it's positive, and is it strong or is it weak? It's pretty strong. They're pretty close together. All right, so we're supposed to decide whether, spelled incorrectly, the model is reasonable. So the fact that it's positive and it's strong, it makes sense, right, that as the car is newer, the price should be higher. That makes sense, right? And it's strong, so we're going to say that this is reasonable. All right. The information she got is pretty reasonable, makes sense. Now it says draw a trend line. Okay, so based on those, draw a line that has about the same number of data points above and below it. Okay, it needs to be straight.
So it's just like a number line? Oh, I know what you're saying, Ski.
Mine was not really straight. I'm going to try again. We're not going to let me try again. Okay. So it should be a straight line. So rulers are great for this. Now, we're supposed to write the equation of the line. Okay, this paragraph down here, I give you kind of hints of how to do this. It says use the slope and the y-intercept to find the equation of the line. Okay, so what is the y-intercept? About
5,500.
a little less than 5,000 maybe? Because 5,000 is like in the middle there. So a little less, so 4,200. Okay, that sounds lovely. All right, so in our equation for line y equals mx plus b, our plus b is going to be plus 4,200. What is our slope? We're just estimating here. Okay, so for every one that we run, how much are we raising about?
1,000.
About 1,000? That seems pretty good. Okay, so we'll make our slope 1,000 because we go up 1,000 and then over 1. All right, so we have an equation. Now, determine whether the asking price is reasonable. Remember, what year car is she wanting to buy? 99. So on our graph, what would that be at? 0, right? Because this is 2000, 2001, 2001. So 0 is going to be our 1999. So is that 4,200? That sounds reasonable, right? We actually think that's where the graph is hitting. So I would say price is reasonable. Okay, so you can use something like this if you want to figure out if the car or whatever you're looking for is reasonable. If they're trying to gyp you.
No cars are reasonable.
No cars are reasonable.
Teacher, pardon this interruption. I need the following students to come.
Alright, so for your homework, like I said, I'm pretty sure it's not word problems. They're just going to give you some points and you got to plot them and then make you're probably going to have to make the equation line and stuff. But it won't be word problems. But the other ones before that will. Okay, I would maybe on the top of your homework write down these two forms because you're probably going to need them. Okay, you need to have these memorized by the time the test comes. Which is in a week and a day. It's next Thursday.